Welcome to our vector graphic GeoGraphics presentation. My name is Tim Schettelbauer. I am a visualization developer at Wolfram. Francisco and Jose are joining me to present this three-part talk. The big change is GeoGraphics in Wolfram Language 14.3 returns vector maps by default. The advantage of vector maps is that it eliminates any resolution issues and adds the ability of styling individual objects. In the summary, I will be discussing the new geo background styles. Francisco will be doing the new tile data protocol, and then Jose will present the new spherical geometry engine, and plus the new additions in Wolfram Language 15. Here we'll start with new default maps styles. The most noticeable change is this terrain texture. And there's also some more subtle changes, like there's label haloing. So it makes like Antarctica down here, you can see it pop out a little more. And roads that will appear gradually. There's 5 new geo background styles. The new styles include terrain, plain, basic, monochrome, black and white. And if dark mode is detected, the dark version of each style will just be automatically applied. Okay, here's the terrain texture. It's got a nice terrain map. And then here's the actual dark mode version too. And here you can really see the text haloing. Plain, this is the default style for all 11 geo-visualization functions. Next is basic. This is similar to the terrain texture, except instead of the terrain texture, it's just a green color. So it's just a brighter map. And then we got a gray level map. And then a high contrast map, which is basically just almost black and white. One advantages of these, you get better geographic visualizations. Like this is showing the GeoSmooth histogram. On the left, you got the new default. On the right, you got what appeared previously. There's, less clutter. It just looks a little nicer. And this is GeoGraph plot, value plot. It's just kind of a brighter, cleaner, and it kind of improves the focus on your data. Okay, another feature is fades. We have the terrain fade, which for the default mode, this terrain, as you zoom in, it'll eventually blend into a flat color. So the middle one shows kind of like an in-between where it looks a lot lighter. And then the roads also start appearing when it gets to that flat color. And okay, and another thing that fades is the roads. They gradually appear as the zoom level increases. Instead of just getting to a zoom where they just pop out, you can see in the middle one, they're just barely starting to come in. And then the one on the right shows where they're fully visible. Another thing we changed was the initial road appearance. The roads appear at a higher zoom level, which is on the left here. There's no roads, but on the previous one, you can start seeing the roads appear. And just as a note, if you ever want to use the previous maps, the previous styles, you can set the geo background to street map vector labels. So, okay, that concludes my part of the talk.
Hello, yeah, I'm Francisco. Okay, I will talk a bit about this new protocol that we have that we are now using. So GeoGraphics vector maps are now using proto-maps as main protocol. So we still support, of course, previous protocols. And the idea is that PM tiles, which is the main format of this proto-map, it's a file specification that allows having all the tiles in one large file. That means that now we have a container and we can share this file if needed, or it's published in a CDN, etc. So we get all the advantage of being there. Also, it's very efficient because it has a directory-like internal structure. So it has, I will explain a bit more about this internal structure. And you might compare this with MB tiles, which is well known also as container of tiles. The main difference is that PM tiles allows accessing via the HTTP range. So any server with a HTTP range specification can be used as a server for these PM tiles, while MB tiles is something that you have to use only locally because it's a SQL-lite database basically with containing all the types. Also, PM tiles is very compact because it removes duplicate tiles, etc. So I will talk a bit more of that. So what's the structure there? So we have this specification divides the file in a header, a root directory, metadata, leaf directories, and tile data. So the header contains all the important information about where is every part of the file, right? So it has the, I'm putting here, we have now also the possibility of having a local low zoom level file, which is included in the new version of Wolfram Language. So that's why zoom levels below 4 are very fast, because now they are included in the layout of Wolfram app. So I'm comparing also both files, the structure. So we have a metadata part, then where the leaf directory starts, where, well, let's move this. So let's start with. So this header contains where the root directory starts, the length, the metadata, initial position, the length, and also if it has leaf directories. For example, the lower one doesn't have any leaf directories because all the tiles can be addressed from the root directory. But for the full planet, where you have lots of tiles, you need to have all these leaf directories. And then also where the tile data starts and how large it is. How many tiles you have in each of the files. You might see that maybe these numbers are not exactly what you would expect for Zoom 4, because these are unique entries, right? So they don't include in this file empty tiles, for example, or duplicate files. Duplicate tiles are included only once, like for example C tiles. That all the C tiles are the same basically, so they need to be included only once. And some extra information about formats of the tiles and the zoom level available for each one as the full range, right? Then we have the metadata part, which contains the layers description and also a bit of extra information about attribution, description, etc. Also, it contains which layers are included in these tiles. So wet, water, waterway, etc. So all this is included in this metadata. Then what it's more interesting here is that how the tiles are stored. So the individual tiles are actually MVTs, which are Mapbox vector tile format, and they get an index, which increases like a Hilbert curve. So, for example, for the zoom 0, we have only one tile, that's the index 0. Then for the zoom 1, we have 4 tiles, and these are the index. And you can see that it increments, so they have a unique integer index for every tile in the whole set. And the main idea of using these Hilbert curves is that neighboring tiles will get will be also a neighbor index. So for example, if I want to, for example, show Canada in a map, I will get these 4 tiles, which are from 5 to 8. That means that I will get only one chunk from the file, because these are contiguous tiles within the file. So that's important, because that means that the server needs to work less for serving one map. So instead of searching within the file system or within the file, very places, different places within the disk, it will be very close in general, right? So for example, if I want to show South America, I will need 9 tiles. And it will basically be 3 groups of tiles. So for this zoom 3, so South America for this zoom 3 will be these 9 different tiles. As you can see, this is a very clever way to organize the tiles, so that we get faster access to them. So the advantage are basically what I've been saying. So good thing is that because it's one file, you can have that as a local file or in the server. You can do one HTTP call with all the ranges you need, and that means less overhead of calling the server. This Hilbert-like indexing makes that less work for the server. Now we can have these permanent cache tiles that are using the same technology and the same access. PM tiles are very compact, so it reduces a lot the storage need in the server. It uses the same standard vector tile. And also something that I didn't mention is that within these PM tiles, you can have also raster formats. And that's something that probably will improve in the following versions. The fact that we could have different layers of raster data also within these PM tiles. And well, that concludes my part. Now, Jose, you will talk. Yep. Thanks.
Hello, my name is Jose Martin Garcia, and I'm the manager of special projects in the research and development group. And so team has shown how much GeoGraphics changed in version 14.3 in regarding styles. Then Francisco has shown that we also changed how GeoGraphics accesses the tiles. And now I'm going to be talking about even more changes in 14.3 regarding the internals of GeoGraphics. So GeoGraphics used to be based on a geometric engine for flat geometry. We changed that to a new geometric engine based on spherical geometry, which is a lot more careful with all the details related to the topology of the sphere and the asteroid in general. In particular, the handling of very large primitives, like very large geopolygons, like also geohemispheres, is a lot better now. So an example is night hemisphere. Here we see the part of the Earth which is currently in darkness. And something we have added in version 15 is the ability of these primitives and the similar primitives like day hemisphere and day-night terminator to have a reference altitude option, which controls the different forms of twilight. This is something that we had in various astrofunctions, but now it has been extended to Geo as well. And so here what we see is these four large regions. This first one is the terminator, which covers exactly half of the Earth. And then the other two are smaller regions, the other three, sorry, are the civil twilight, the nautical twilight, and the astronomical twilight. So this is the region of the Earth which is dark enough for astronomical observation. So, for example, we can now show the same primitives in other projections. So this is the orthographic projection. And so we can now, for example, show different parts of the Earth. We see very neatly the 6 degrees bands. So these bands are defined by 6 degrees with respect to the default terminator. We can change the projection, and now we can do the same type of description. We can use the bone projection, the Molvide projection, etc. Right? So this works now in all the projections of GeoGraphics. Something new in Wolfram Language 15, the upcoming version, is a new option for GeoGraphics called GeoAccess. So there have been multiple reports of users saying that we didn't get right the latitude coordinates in the Mercator projection. This is because these numbers here are not latitudes. These are the projected y coordinates. The latitudes are these ones, and these are the numbers that we now can see activating the GeoAccess option. So these are longitudes, these are latitudes. And you see how in the Mercator projection, they are not uniformly distributed. In fact, the pole is pushed to infinity vertically. We just cut here at 85 degrees. We can select where the axis will cross with this allied option, GeoAccess origin. So for example, I'm here having the axis crossing at our location in Champaign. Notice that the 0 is still at the equator or at the Greenwich meridian. It's just that the axis cross there. They can be used in any projection. This is a map that Stephen showed in his keynote without the axis. And so here we can understand now these lines. Of course, these axes here are the projected coordinates and have nothing to do with latitude or longitude. Right? This is the latitude axis, and this is the longitude axis. So it's quite deformed in this projection. We can have another manipulate, as we did before. And so we see how we can move the axis vertically in latitudes or in longitudes. Right? And the numbers will follow along. And here you see also that you can typeset the axis as you want. You have full freedom as usual. We will also support in version 15 arbitrary axis objects wrapping geopaths. And so here's an example in which I create a geopath from Buenos Aires to Tokyo, and then I add these ticks, which are just the distance along the path. So very useful, for example, for plane tracks with dates or whatever. Any path can now be converted into an axis object. Okay, let's continue. Another thing which is new in version Wolfram Language 15 is the ability to use night hemisphere again, but from any other celestial body. And this is useful in astro. For example, imagine that we take a date of now plus 7 days, so 7 days from right now, and we show a map, this is GeoGraphics, of the moon with the night hemisphere. So this is able to compute where is the sun, how is that going to affect the shadow, the hemisphere, and we get that. If we look at that geographics during a full synodic month, so the 29.5 days, we get something like this, which shows all the phases of the moon, and also shows that because the orbit of the moon is elliptical, it's getting farther or closer away from, and you see how it changes sizes. It also wobbles a little bit. That's called libration. And so here you have everything all together computed by GeoGraphics. We can do the same thing for other bodies, like for example, Venus. This is a view of Venus. And if we compute a full period of 594 days, we get something similar. And now the change in size is very large. Also notice how Venus is rotating backwards. Yeah, so that's the moon. Sorry, that's Venus phases. And let me evaluate this again. Sorry, I think I broke something here. Well, let's continue. So another example provided by Jeff was this image taken from the moon of in 1969 of the Earth, and here, if you zoom in, we can see here Australia. If we reproduce that, we see this is the view. Right? It needs an additional rotation, but this is the view exactly at that time on that date. Okay, and to finalize, I want to show a fun function that was added in version 14.3. It's called GeoReposition, and this is a function that allows you to move any polygon somewhere else on Earth. For example, this is a map that takes the polygon of Antarctica and moves the South Pole to our location in Champagne. So now you see how Antarctica appears here, and you see how the sizes change a lot, right? Because this is the rectangular projection, it's not area preserving, and so Antarctica has been moved from there to there. So we can do another example. In this case, we are going to take the polygon of Australia, and we are going to move Melbourne to some arbitrary location. So that's Melbourne, and so now I'm going to move, for example, in longitude, and I can move in latitude. And you see how it changes. This is a Mercator projection. And so here we can see how, even though it looks smaller than Greenland, it's actually larger than Greenland. I can rotate it even. So these additional parameter controls a rotation around the location we specified. And this can be done anywhere on the Earth. Okay. And to conclude, as we mentioned, GeoGraphics has changed a lot, has been significantly upgraded in the last two versions, version 14.3 and the upcoming version 15. We have new styles, we have vector maps by default, we have new data protocols, and we are adding now new options and many other things. Our plans for next year is to add more geocomputation functionality, more geodata, more geoformats, and also provide access to styling the many individual geometric elements that vector maps have. It's in the order of hundreds. Well, we invite you to check out the extensive geo documentation, including the main pages like GeoGraphics or GeoBackground. And then there is a guide for all the visualization functions that Tim was referring to. And there is a geography tutorial which explains all the details of how to work with geo in Wolfram Language. Okay, so we have a few minutes for questions. Let me check.
Yes, there was already a question that I answered, which is maybe we can read so everybody knows.
Yes. is it possible to toggle location text labels on and off for all maps? Yes, as Francisco showed, each version of the geo backgrounds has a no labels version. And so if we have, let's see if I can evaluate here. If we have GeoGraphics.
Each vector version, by the way. So,
Yes,
you know.
exactly.
And this stream map also, which is the all
Right.
default.
So if we have here, so this would be geo background goes to terrain, that would be the default. And if one wants the, this changed. Okay, if one wants the version with no labels, this would be no labels. Also, if you want the dark version, we can do dark here. Which would be the map you would obtain if we were in dark mode.
And if you want to force the light version while in dark mode, you can use light.
Exactly. If you are in dark mode and you want the light version, then you can do terrain light. Yep. Okay. Any plans to be able to connect to geo servers using different protocols currently supported? We have a geo server option, which is able to communicate to external geo servers with some protocols, like standard XYZ protocols. We have some support for WMS, WMTS, but I don't know this one. www.eos.com land viewer. We will check how it works. But I would invite you to check the GeoServer documentation, and there we explain the possible examples and protocols we support. Well, if there are no more questions, I think we can stop here. If you have questions, feel free to contact us, and we'll be happy to help. Thank you so much.